In this video I'll do number 9, and this is about a propane tank, an industrial sized propane tank that has two hemispheres attached on the ends of a cylinder. So the tank volume would be the sum of the sphere and the cylinder. And it says the length of the cylindrical part of the tank is 4 times the radius. So on my diagram I put the radius in, and I have made the length of the cylinder 4 times r. So this is the given in the diagram, and it says write a function v that represents the total volume of the tank in terms of r. Use the graphing calculator, graph v and sketch it, and determine from the graph on the calculator the radius and cylinder length when the volume is 120 cubic feet. So we also want to know if the volume is 120 cubic feet, what is r and L. So the unknown is r and L, and we're going to let v represent the volume of the tank, and r is representing the radius. Okay, so that's the given, the unknown. The equation is that the total volume of this tank is going to equal the volume of the cylinder plus the volume of the sphere, because the two half spheres make a whole. So volume of a cylinder is pi r squared h. So pi r squared, and in this case the h is this length that's on our diagram, 4r. And the volume of the sphere is 4/3 pi r cubed. So that's our volume that we're going to graph, and that's a function of r, so we can write v of r. And on your calculator that would be the y1 equals. You can put that in that way. And I'll graph that and we can take a look at it. So when we plot this function on the calculator, we get a graph that looks like this. And in terms of the ymin and ymax, well, I know that the other graph that I'm going to put on here is I want to find out when is the volume equal to 120 cubic feet. So that's going to be my y2. So that's this line here. I want that to show up. So in that case, since I know I need to be above 120, I'm going to pick 200 to be my y max, and I like to see the bottom axis, so I'm going to put minus 10 to be my y min. Now, in terms of the x, well, x is going to be r, because remember that these graphs, they have meaning. This is a volume versus radius graph. Y is the volume, x is the radius. So in terms of a radius, I'm going to have a volume of 120 cubic feet. I'm thinking that the radius probably won't exceed 20. We could make better guesses, but I'm going to say it's not going to exceed 20. And when we do that, I get a graph that you can see a cubic function happening here. And clearly, this is the intersection point. And at that point there, I'm going to get the r comma v value that gives me when the volume is 120. So I did a calc intersect on that. And with the calc intersect function, I find that it says that the x is equal to 1.928 and y is equal to 120. So that means that the radius, in order to get a volume of 120 cubic feet, the radius has to be 1.928 feet. And that's the answer that was asked for. The one other thing it asked for is the cylinder length, and since the cylinder length was 4r, that would be 4 times that. And that's going to be 7.712 feet. And if you wanted the overall tank length, you would have to add the radius plus the 4r plus the radius again. And if you did that, you'd get a total length. They didn't actually ask for this, but the total length of the cylinder is 11.568 feet. That would be the overall cylinder length, including everything.